Now there was a question in evening shift that what is the hybridization of cobalt in this particular coordination compound. Now let's first understand how can we calculate the hybridization of the central atom in any coordination compound. First we have to calculate the oxidation number of the central atom. Let us suppose it is X. Ammonia is a neutral ligand. So the charge will be 0 here. The overall charge on the complex is +3. So oxidation state in this particular complex of cobalt comes out to be equal to +3. Now if we carefully note the atomic number of cobalt, that is 27. So the configuration, outermost electronic configuration will be 3d7 4s2, but here in the particular compound the cobalt is in +3 oxidation state. So for a cobalt 3 positive ion, the electronic configuration will be equal to 3d6. Now if you remember, we have done a topic that splitting of d orbitals in the presence of octahedral field. During that splitting we have done that d orbital split in the two base pairs. The first one is named as T2G and the other one is named as EG. Now in this particular case it has been found that the 6 electrons in the case of cobalt 3 positive, they reside in T2G orbitals. So making it as a T2G6, that is fully filled orbital, and EG 0. So that means all the electrons, they are paired up in the case of cobalt 3 positive in this particular complex. So that means if we want to calculate the hybridization, so we know that there are 5d orbitals. So this is our 3d, 1, 2, 3, 4, 5 and 6. Next we have 4s and then we have 4p. As the number of the ligands present in this complex is 6, so we need 6 empty orbitals here. The first ammonia will reside here, the second one will reside here, the third one here, the fourth one here, the fifth one here, and the last one here. So the hybridization in this case will be D2sp3. So hybridization of cobalt in this particular case is D2sp3, and this is basically a inner d orbital complex.